Hello friends, welcome to Eason Academy. We are discussing about microprocessor as a part of embedded system programming, and today is session 8, and we are going to discuss about input. Okay, like what we discussed previously as an output. Now we are going to discuss about input. So with that, fairly that thing is going to be complete. So every microprocessor based system has these 4 units. One is microprocessor, ROM, RAM, output, input. That's it. This for computing. This is for computing. And this is for external. External interface or connection, whatever it is. The beauty is both of them are controlled only by microprocessor. Microprocessor to memory. Microprocessor to IO. Understand? Okay, so this is what, but understand one important thing. The microprocessor can do only 2 activities outside. It can do write or read. So here, first thing is write to memory and write to output. And there's one more thing called read. Read from memory and read from input. Am I right? That's it. Please understand this is, if you have the only 2 operations at the top level. The top level, there are 2 operations, read and write. Out of 2 operations, one operation is write to memory, that is on the RAM. It cannot write to ROM. Okay. Then write to output. Then read from memory, either from ROM or RAM, and read from input is from input. This is what total. You'll be very surprised. All your embedded world is only running with these 4 ideas. Now let us see that in the software, when you write a program, you write a program like this: int star x. X is equal to 32. Star x is equal to 1. Now what is happening? You don't know whether you are writing into memory or output because it's writing. You don't know you are writing into memory or output. That depend on the memory map. If I say here 31, in our case, we have used 0 to 15 for ROM. 16 to 31 is RAM. And 32 is output. And 33 is input. Understand? 33 is input. Now, if I say that x is equal to 31, 31 belongs to RAM. So the 1 will be written here. The 1 is a number now. But when I write the same thing 32, what is happening now? What is happening? It is becoming output. So that time this is going to become 5-volt controller device. So this address Yes, one number changes either a memory or the output device. So this is depend on the memory map. How do you do that? How do you do that? That we have discussed. We will discuss. Keep on that, because this is a one very important memory map. This will be discussing repeatedly, and this one we'll be using repeatedly. These are the one we are going to do it our entire course. Entire course will be using only 1, 2, 3. That's all. Nothing more than that. How do you do the process? That is what the trick for programming. Now, let me write a program now. Now let me write another program. See that. Int star x, comma y. Now I say x is equal to 33. X is equal to 33. Y is equal to star x. Now star x is coming on the RHS side. Let's read. Now what the microprocessor will do now, the microprocessor puts the address as 33 because x is 33. Then it puts right 0. I'm not writing. I'm reading. Read as a 1. And then data. Now what happened? I have a tri-state switch. Is the input. A switch. Eight. I0, I1. This is switch. So D0. These are all connected to this guy. This guy is having 8 wires. So D0 is connected to D0. I'll write like this. D0 is connected to 0, D1, D2, D7. Done. Now here, the input, I normally, let us assume that I take only one. Don't take the other ones. Leave it the other one. I connect everything to ground. So all 0 volt. This one, I connect with the resistor to ground. So this guy is 0 volt, like them. Here also I put a resistor. Now this guy is 0 volt. The trick here is I connect a switch here and connect it to 5 volt. When the switch is not pressed, you get here 0 volt. And these are all will be 0 volt. All will be 0 volt. Now I write a program. See that. I write a program now. Y is equal to star x. I'm reading. When I'm reading, switch is not pressed. I say while y equal to 0. While is equal to 0. See that what I'm doing now? While y is equal to 0. That means that I read the x and no button is pressed. I get 0 input, all zeros. Oh, comparison. Then I do once again, y is equal to star x. I read once again. That time also. So what happened? This guy will be keep on in the loop. He will never get out of the loop. He'll be waiting for you to press the key. The moment you press the key here, what happened? Let us assume that. You press the switch. When you press the switch, you make a contact. So this guy get 5 volt. So this guy get 1. So what happened? Now the y become 1. So y become 1. This condition failed. So this guy will come out. Here you write any program. Here you can put x is equal to, 32. Star x is equal to 1. You will connect to the output port. Connect to the output port. Understand? This will be a 32. This will control the bulb. That means that normally bulb will become off. And when I am trying to, when you press the switch, you can take any active. See, I'm not worried about what you are going to do here. That is called processing. That is what we are going to discuss for the entire next full duration. How many months you attend, I don't mind. Whether you attend 2 months or 4 months or 8 months or 12 months, I don't mind. Till you do a right project. Till you say that, sir, enough. I will be teaching you. No, don't worry about that. Till you are having a confident, doing everything you can be with me. That's the way I schedule the whole system now. So do you understand that? That is how I'm reading. But the problem is here. Here, when I do the output, once I write it, it is written there. It is latched. This is a latch. The output is a latch. Please don't get confused between the output and memory. But the input, once you read, it will be stored Y. Suppose if you don't read here, let us assume that I'm doing a while Y is equal to 0. When I was reading, you did not press the switch. The switch is not pressed. When you are reading, the switch is not pressed. So Y becomes 0. Now Y will be always 0. So you'll be always a loop. Even if you press the switch, the Y become always 0. That's why I'm doing here Y is equal to star X. I'm reading. The problem is this. Only when I'm reading, this will come. You need to store it on Y. You need to store it. Whereas the output is latched. Input is buffered. It's not latched. When the switch is on, it will come. The moment switch is off, it's gone. If you don't store it on X, if I do like this, star X, then you're gone. It is not stored. That's why we write Y is equal to star X. I'm reading and I'm storing. I'm reading, I'm storing. I see that. I have seen this problem. People so many times write, they read Y is equal to star X, but they never read it afterwards. So they say, sir, it's not coming out of the loop. How it will come? You have to read once again. So what we are doing is we are reading and storing out to the case input. This is all about input. The output is latch, input is tri-state. By controlling your this one, there's a signal here, enable, which is having, as usual, a gate. Always there's a, understand one thing, there's a gate. Select and read, because this is only a read. Now what happened? I take the address. We take the address, put a name 33 and out here. When you give 33, then only if we give 34 here, this becomes 34. This will not. Like this, as I told you that you can have n number of buffer, 33, 34, 35 like that. So the system, you can have n number of latches, n number of tri-state buffers input. So don't think that there's only 8 pins. You can have 8, 16, 32, 64, everything. Any number of input pins, you can have it. So this is the way the input work. So a system is like this. A system can be drawn like this. Central CPU. CPU is a CPU. It's a microprocessor. It's a microprocessor. Then I have an input. Component or tri-state buffer. And I have output. And there is a device, input device. and there is a output device. So you connect the input device to the input component and read it. So you cannot, this is not possible. You cannot connect input device directly to microprocessor. This is not possible. Same way, microprocessor cannot talk to the output device. That is not possible. It needs a component to do that. And this guy will have address 34, 33 like that, 32, 33 like that. There's address. This is address of the device. Okay. How do you control this? By writing a small program. You write a program, int star x is equal to 32, star x is equal to 1. This is output, because the pointer is on the left side. So you are outputting to the here device. Now, if I change the program like this, we change the program, int star xy, x is equal to 33 and y is equal to star x. Now what I'm doing, I'm reading from the pin. That is what this 33 is, a right hand side. Is it clear? How we are connecting the input and output. Any doubt on this? So please understand, if you take a real world, when I was doing it in 1980s, we used to have a microprocessor. Let us assume that 8085, the name of the microprocessor. Like today you say Core i7 and like that, there is a microprocessor called 8085. And then there is a ROM called 2764. That's the 8K chip. Then there is this guy has 16 address lines, 8 data lines. I'm giving a small example. Then I have a RAM 6264. This is 8K. I have a chip called 74373. That's a latch output. I have a tri-state. I have a tri-state buffer input 74125. I'm giving you an example. So what we do here is we buy these components and we connect them through the wires, a board. We buy a board and put the ICs and connect them. Later, people did one beautiful thing. What they did was, that's a trick. They did was very interesting one. They put inside the single silicon. Let's say this is silicon. Single silicon. They put inside microprocessor, ROM, RAM, latch, and input buffer. This is a silicon. This one is a silicon. And they make a connection here to the outside world, 2 pins. the output and input pins. But this will be inside. This latch will come out and the tri-state will get in here. Input output. Understand this. This is called, this whole thing is put like this and finally made as a single IC. Called microcontroller. No difference. They put it inside the silicon, that's all. Instead of putting it on the board, they put it inside the silicon. Nothing will change for you writing a software, everything. All are same memory map, everything. So they made your life easier today. You can buy a microcontroller. We call microcontroller. The P becomes C here. Then you have input pins. You have output pins. And you have a ROM here. You have a RAM here. And you have a microprocessor. This is called microcontroller. Now you write the software in your PC or laptop. Then you connect to them through the input wires. This guy. That we will discuss later. Maybe next week I'll explain to you more clear. After connecting, you write a software here. Int star x. X is equal to 32. Star x is equal to 1. You write here. Then you compile. After you compile, you get the, let's say this is test.c. You get test.binary file, whatever it is. Test.binary file, which only this guy will understand who, microprocessor. Then through this connection, there's a software available called downloader. With that, you can able to put that into the ROM. That process is called flashing. I'll explain to you next week what is called flashing, how exactly it's getting flashed into the ROM. I told you ROM is a read only. Now I myself is telling that you can change the ROM code. So that means that we are writing into the ROM. We are writing into the ROM. There looks to be a confusion, but I'll clear the confusion next week. We'll go slowly. No hurry. I'll go slowly. But right now, I'm trying to give you a concept. A microprocessor, with the help of software, you can control the input, you can control the output. Now, for make your life easier, they put all these things latch and everything inside the single chip. But unfortunately, if I give you a chip, you cannot handle it. What people do here is take a PCB board and put a connector. They put a connector and they put a microcontroller. They connect them. So you can take from the connector easily. This is what the board, this is what your Arduino and other boards. These are called actually microcontroller development board. Okay. Is it clear? If you have any doubt, let me know. What is so? We have three things. Please understand. We have a microprocessor for which you write the software that is stored in the RAM, and RAM for variable. And we have IO. Now we put everything inside the single chip called microcontroller. This is IC. This is IC. Now this microcontroller is getting to the board, because you cannot use the chip directly. The pins are going to be, how do you connect them? So that's why they make a board, which you can easily connect the wires and do the experiments. They can put even LEDs and LCDs, whatever it is. You can make everything. This board is called microcontroller development board. Then from the PC, you will make the connection. Nowadays, we make a connection through USB. So because USB is also giving a power. So they take the power and the connection. So by using a software called downloader, these are all simple process. The most toughest process is writing a software for the microprocessor. That's why I always say that master C programming. So before coming Monday, next week, try to practice as much as programming on microcontroller. That will be good for you. Understand? Practice as much as C programming. Not forget about this. This and all I'll explain to you next week. And we also see a simulation. But I want you to know the C programming. So what I have explained so far is quite simple in the microprocessor thing. There's a microprocessor which does only two activities outside: address, write, read, and data. Only simple commands: int star x, x is equal to 32, star x is equal to 1. This is output. This is output. Same thing if I write like this: int star x comma y, x is equal to 33, y is equal to star x. Now you are taking the input. Am I right? That is what all about input and output. And I told you that this microprocessor does three activities. One is input, output, that is read, write. And third one is processing. This is what's the most important. This is what all about your C programming exercises. The industry is not giving priority for these two. These two are quite simple. Only the two statements. The most important thing is you should know processing or execution. This is what you are practicing on the C programming, which will be very, very helpful to you. So whatever level you can try in next 2-3 days, that will be helpful to you when you start coming on Monday with our embedded programming. Sorry, embedded system programming, please. Okay. If you have any doubt, you can ask. Otherwise, we can wind up the session today. Let's not go in depth. I don't want to push you a lot of things. I've already talked about two critical things today: input and output. Go and watch the video when you have a time. Anyway, I'll upload it tonight. Watch the video. That's very important. Wherever you have a doubt, come back to me. Okay. And this is enough. You will do wonderful project. Whatever we discussed so far is enough to do the projects. Okay. I'll also tell you that what we are going to control initially. Let me tell you only 1 minute before we wind up. With this microcontroller, we connect LED, 7-segment, dot matrix. And input is switch and keypad. That's also indirectly switch. These are the ones you will do a lot of experiments. Like we have so many exercises in the C programming. We have so many exercises in the motion. So please, these are all go very slow approach because this is a skill. Skill requires a very slow and steady process. Okay. Thank you. If you have any doubt, you can ask me now. Okay. So fairly, we have discussed the basic requirements. Basic requirements are discussed. With that, we'll proceed to the next week sessions and make sure that you practice the result. See, if you understand what we discussed in the 2 weeks very clearly, nobody can shake. This is the fundamentals. This is a very fundamentals of embedded system programming, C programming and microprocessor. But coming weeks, we discuss about more and more on knowledge-based system. All your questions will be answered like this. So we discussed like this. The middle, we started microprocessor. Then we go up microcontroller, embedded systems like that. And in the bottom, we go down to the digital electronics. That is gates, logics, and RAM, how they are working. Then we go down electronics. What is electronic? Then we go down what electrical. So this is, we divide the whole thing into center. So we started from here. Normal approach used to be from here, but that does not work. That I've seen. Because we have given this, we'll be able to sorry, there was a small delay. I got an important call, so I need to do that. So is it clear, Vijay? Hello, Vijay, you are there in line?
Oh, yes, sir.
Yeah. Do you get to know the concept of the whole thing now? The 2 weeks is a very critical for you. If you could able to get into the things.
Yes, sir. Actually, I'm trying to revisit all the videos, sir, because I missed 1 or 2 classes.
That doesn't matter.
Project,
yeah, that doesn't matter. Yeah, that doesn't matter.
I'm trying to review, and as for you have sent me Google Drive link where you have level 1, level 2, and level 3. So
Correct.
I will try to close level 1, which has around 24 problems in that. I will try to close that, and I will send you by this Saturday or Sunday. So that I think I will be around basic in terms of programming. That's all, sir. Actually, I have to read because the